All right, so in this spell work here, I want us to notice that we're going to be solving for x, and you have exponential equations. So what you have to do here is what we learned last time is if the bases are the same, they will cancel, bringing down the exponent. Like both of these have a base of 7. And because they do, the bases will cancel. And now I'm just left with, in this case, 9 minus 2x equals x plus 3. And then to solve this out here, is just your basic algebra 2 problem. I'm going to move the 2x to this side by adding 2x to both sides. And so this part cancels. 9 equals 3x, 9 equals 3x plus 3 comes down. And then maybe I'll subtract 3 to this side so that way x's can be by itself. This will be a 3x and a 6 here. There's still a 3 on this x, so I'm going to divide off a 3. So x is equal to 6 divided by 3 is 2. And so my answer here is x equals 2. It's kind of a weird bubble. Let me do that again. And that's it. So we're going to try to make the bases the same. To do that, now notice how this one here, 4 and 2 are not the same base. But here's the thing. We can make the bigger number, the 4 here, have a base of 2. If we just think about how or what power does this 2 need to be to make a 4? Well, 2 to the second power makes a 4. But keep in mind there is an x that was in the exponent to this 4, so we bring that x down. So now it's like a 2x, 2 times x. So we switch the base so that they can be identical. Now I'm going to bring down the 2x plus 6. I want to keep this side the same because I want to have the same base so that they can cancel. Because both sides now have the same base, they will cancel, and I'm really left with 2x on this side and x plus 6. To solve out this problem, I'm going to subtract x to both sides. This cancels. I have now a 6. 2x minus x equals x. And I think that is it. I have my my x value. Let's try it with this one here. This one's a 10 and this one's 100. I'm going to try to change this 100 to a base of 10. Generally, you want to take the bigger number and see if you can make it the smaller base. It's easier to take bigger numbers and make it have the small base. So 10 squared gives you 100. So I can write 100 as 10 squared. I'm going to bring down the x here. And I'm going to bring down the 10x minus 4. Now both sides have the same base, so they get to cancel now. And I can write this as x minus 4 equals 2x. So from here, I'm just going to, maybe move this x to this side so that way they can all be on the same side. This would cancel. Negative 4 would come down, and this would be 2x minus x, which is just an x. And so my x equals 4. And I'm done. So I hope this kind of gets you into the idea that if you have the same base on both sides, they will cancel. And that's kind of the key thing to today here that's going to really help us out. So let's talk about inverses today, because that's today's topic. All right. So inverses, I think you guys are starting to notice that we've been learning a lot of logs or logarithms, and we've been learning a lot of exponentials or exponents because they are inverses of each other. They can be used to cancel each other out when the bases are the same. So here's what I mean. This here, 14, is raised to the log 14x power. Now that's kind of weird to see. But anytime you have an exponent here and a log, what happens is if their bases are the same, which in this case, this base is a 14, this log's base is a 14, they cancel out. The log and the bases cancel out, leaving behind the x. So x is all that is left. Same thing for this case. There's a log here and has a base of 14, but you also have an exponent or an exponential here, 14 to the x power. Because they both have a base of 14, they all cancel out. So in this case, both bases and the log cancel out, leaving behind just the x. that was here, or the exponent. And there we go. So basically, if you want to cancel each other out, if you have a log, you use a base to cancel out, or an exponent, or exponential is really the word. If you have a exponential, you use a log to cancel that out. Yeah, so log and bases kind of go hand in hand, or logs and exponents. So let's do a few examples here from the homework before we get into today's lesson. Okay, so in this slide here, let's do some homework problems from page 5. I just picked out a few ones for us to do, and this is the ones where you just need to simplify. So notice how the first one here is a log base 3, and this is an exponential inside the log, 3 to the x power. What I immediately notice is that there's a base of 3 on the log and the exponential. So that tells me that they are going to cancel, because when they're the same base, they're going to cancel, which means that the 3's goes away and the log. So now you're just left with an x here. Oops. Just with an x, and that's it. So the log and the bases cancel, leaving you just an x. This next one here, notice how this has a base of 10 and this log doesn't have a base. So by default, we know that the log has to have a base of 10 if there's not a base written. So that's a base of 10, that log's a base of 10, they're going to cancel. And that leaves behind just the 2 that was in the exponent. So that there is my final answer. Now some of these get pretty tricky. So this one here has a log, and there's no base written, so I know it's 10. So I'm going to put a little 10 here. And then what I notice is that there is a 1,000 here. As a base. And I can't cancel them out because they're not the same base, but I actually can write 1,000 as a base of 10 if I do 10 to the third power. But keep in mind, this 1,000 has an x as an exponent, so that x is going to be attached to this 3 that's an exponent. So let's rewrite this to make this a little bit clearer. So this is really log base 10, 10 to the third power, and then that x that was next to the 1,000 gets attached to the 10 to the third power. Now when I look at this, I'm like, oh, both of the bases are 10s, they cancel, and now I'm just left with a 3x. So my answer here is just 3x, and I'm done. All right, let's try out this one here. So this one's same scenario as number 3. This one has a 5 as a base, and this is a 125. At first glance, they don't look like they can cancel. But if we really look at 125, we can manipulate it to have a base of 5, and 5 to the third power, 5 times 5 times 5, gives you 125. Don't believe me? Try it out in the calculator. So I can rewrite this as log 5 to the third power, and then drop that x right next to it. Once I do that, I immediately notice the bases are both 5s, so the logs are going to cancel and the 5s will cancel. So this is really 3x as my answer. Kind of the same as number 3. All right, number 5 here. Now this one has a base of 13 and this log has a base of 13, so they'll naturally cancel, bringing down just the 4x in this problem. So this is going to equal 4x, and that's really all I can do. I can't really simplify anything further than that. So this is it. Okay, so I hope this is starting to give you an idea of inverses with logs and bases. Basically, logs and bases help cancel each other out, or logs and exponentials help cancel each other out. So use that to help you out. So let's do some solving first, and then we'll get into how do you find inverses. So this one here will ask you to solve for x. When you're solving for x here, you want to first think about, okay, where's x? X is inside the parentheses. Notice how this log base 2 is in the way. Like if I got rid of the log, I can get to the x. So to get rid of a log base 2, well, to get rid of any log, you use a base. So we're going to use the same base, so base of 2, and that's going to wipe out the log and the base. So the 2 goes away, both of these 2, and the log goes away. But here's the thing, anything you do to one side, you have to do it to the other side. So I have to use a base of 2 on the other side. So x x minus 5 drops down, and now this 3 is an exponent to this base. So this is 2 to the third power. 2 to the third power is actually 8. And then when I look at this problem, it's like, oh, this is just a normal algebra 2 problem. So I'm going to add 5 to both sides. This cancels. X is equal to 8 plus 5, which is 13. And then there is my final answer. All right, B here is next. So B here has a log base 9x equals 5. So again, x is inside the log. To get to the x, you have to remove the log base 3. So to do that, you need a base of 3. So I'm going to put a base of 3 here, and that's going to cancel out the log and the 3's. But then I have to base this side as a 3. So 9x drops down. I have to ask myself, what is 3 to the 5th power? Because this 5 is now an exponent to the 3. So 3 to the 5th power turns out to be 243. I'm going to divide by 9. And now x is equal to 243 divided by 9, which is 27. So I'm doing this with a calculator, by the way. I do have a calculator beside me. And that's my answer. I do want to also mention, remember, logs don't like to have negatives or zeros inside, so do check your answer. But I was kind of mentally doing that. Like if I plug 13 into here, let me grab my blue pen. If I plug 13 into here, this is just a 13 minus 5 is 8, and that's a positive number. 13 times 27 that I got for x gives me another positive number. I believe, let's see, 9 times 27 gives you 243, which is a positive number, so this is fine. So make sure you do plug it back in to double check, and that's only if you're plugging in into the inside of the log. This one here is a little bit tricky. Notice that this is log x 625 equals 4. So to do this problem, one of the things my students will suggest is like, well, can't we just do the same thing as before? Like the base here is x. Why don't we just base it x? And I'm going to agree. Just use a base of x. That's going to cancel out the log and the bases. The only thing is that you have to do a base of x on the other side. So 625 comes down, and this is x to the 4th power. So a lot of people hesitate to use a base of x because they don't want to cancel out x. They don't want x to fully disappear, but they forget that you have to use the same x or the same base to the other side, so it doesn't disappear. Now, to get this x by itself, it has a 4 as a power. So we're going to take the 4th root. In order to get rid of powers, we use roots. So we have to use the 4th root on this side here. So this is going to cancel. The root and the exponent cancel, so x comes down. So this is going to be x. The 4th root of 625 is 5. So just use your calculator, hit math, go to option 4 or 5, and you should be able to find the root button. And so this here is my final answer. Now, I don't really need to check this answer because in this case, you will notice that this 5 is a base, and it doesn't matter what my base is. You're always allowed to plug in the base. It's just when you plug it inside the log, it's finicky because it only takes positive number. It doesn't take zeros or negatives. So this one here is valid. In fact, all of these are valid. Okay, let's try out a homework problem over this stuff first before I show you how to find inverses. Alright, so this is page 6 of the homework packet on packet 12. So this one is just going to first ask you to solve for x, and that's just basically trying to get x by itself. So like you'll notice in this side here, x is inside the parentheses, so I just have to get rid of the log base 4 first. To get rid of a base, to get rid of log, we use a base. And we have to use the base of 4 to cancel out with this log base 4. So I have to use a base of 4 on this side. So that gets me 4x minus 20, and this is 4 to the 5th power. 4 to the 5th power is 1,024. So now I'm going to add 20 to both sides so I can get x by itself. 4x comes down. this becomes 1044. And if I divide by 4, I think this will be a good number here. If I divide by 4, this is 261 is what my calculator says here. So this here is my answer, and I do want to double check, but it looks fine to me. Like if I multiply this really big positive number to 4 and subtract it with 20, it's still going to be a positive number. So this is definitely a valid answer. All right, this one here is a little bit weird. Remember, this is the one where you have a base that's an x, right? So to get rid of this x as a base, you gotta have to use the base of x. So we're gonna use the base of x, and then that allows us to cancel. But we have to use the base of x on this side, or the other side, basically. So now this is 216 x to the third power. And, well, to solve this problem, I have to get rid of this cubed on this x, so I can get the x by itself. So take a cube root, and I have to take a cube root on the other side. So the 3's cancel, and x comes down. The cube root of 216 is 6, and this is my final answer. Let me just box that in. I feel like I make the weirdest shapes for circling my answer. It's a cloud, sometimes it's a box, it's a circle. You never know what I'm about to write. So x equals 6, and this is a valid answer because you're going to be sticking this in the base, not inside the log. So this is fine. All right, let's do some inverses here. Alright, so when it comes to doing inverses, you might remember that to start finding the inverse, you have to switch x and y and then solve for y. It's basically what you do. So first step here is to switch. I'll write the steps as I go. Switch x and y. So if I were to switch x and y, this would be x equals 3 to the y power. The second step here is to solve for y. So that means that this is, I have to get this y by itself. And to do that, what I have to do here is get rid of this base. Okay, so let's think about it. I don't think we're used to this yet. So turns out to get rid of a base, we use a log to do it. So what I'm going to do here is write a log, and I'm going to use a base of 3. And that looks really squished, but that's what's going to be happening. I have to use a log base 3 on this side because I decided to use it on this side. So what's happening here, let me rewrite that so that looks a little bit clearer. This is going to look like log 3x equals log 3y. So what happens is that the log that has a base of 3 that you decide to use, they cancel out the 3's in the log, bringing down the y. Now this is log base 3x, and the y is by itself, and you've solved for y. So step 2 is completed. Step 3, it's a pretty simple step. You're going to replace y with the inverse y. So actually, let me erase that. So I'm going to make this y here. So what I do is I say that this is y to the negative 1, and this is equal to what the equation I just found. So this is equal to log base 3x. And that's it. That is my final answer here. This is the inverse of this original equation. So the reason why you don't want to just say this is y, because y didn't originally equal log 3x. It equaled 3x, right? So what you have to do is call this the inverse using that -1 symbol, and that defines it as an inverse. So let's try this out with the other log equation. Let me separate these two. There we go. Okay, so first step here, you're going to switch your x's and y. Done. And also this is a base of 10, so I'm going to write a little 10 here. Now you're going to solve for y. So y is inside this log. To get rid of this log here that's in the way for y, you need to use a base. and a base of 10 to cancel out the log that you have. But then you have the 10 this side, or base that side. And so this is y equals 10 to the x power. And now when I look at this problem here, y is by itself. So the inverse of y, we're going to replace y with the inverse of y, is 10x. And this is our final answer. All right, let's do some homework problems where we're finding inverses. I think that would really help us out here if we did some inverse problems from the homework. So here are some inverse problems that I've chosen from the homework. By the way, this is still page 6 of that packet if you are curious. And I'm going to do problem 5 here. And they're just finding inverses. So the inverse, starting out, you need to switch your x's and y. But before I do that, I also want to mention something you need to assume is that if they, notice how this problem uses parentheses around the x plus 1. This is saying that this x plus 1 is inside the log. Notice how this log doesn't have any exponents. So you cannot assume this 3 is attached to the log. You can only assume what's next to the base of the log is attached. So what I mean is x is attached to this log because it's next to it. But you cannot assume that the 3 is attached. So one of the first things you need to do to find the inverses is switch x and y. So let's go ahead and do that. The next thing you need to do is solve for y. Y is right here. But one of the things I want to mention is when you're solving for log, make sure you try to get the log by itself first. Like this log is not by itself. This log base 2y has a 3 attached to it. So I'm going to remove the 3 by subtracting it over first. You want to try to make the log by itself first. So x minus 3 don't combine, so I just drag them down. And then from here, I notice this is a log base 2. So the y is inside the log base 2. So I'm going to cancel out the log by using a base of 2. Y drops down, and this is 2 to the x minus third power. And now I almost have my equation here. This is just y to the negative 1 equals 2 to the x minus third power. I'm just writing it as a inverse equation. All right, this next one here. So again, we're going to switch our x's and y's. And then from here, just like logs, you want to try to get the exponential by itself. This is y 2y minus 3. So to get this exponential by itself, we need to subtract 1 from both sides. So this becomes x minus 1 equals 2y minus 3. And so what I need to know is, how do I get rid of a base? Well, to get rid of a base, you actually need a log to do that. So you need a log base 2. I'm going to do a log base 2 on the other side. So anything you do on one side, you got to do it to the other. But I'm doing a log base 2 because I want to cancel out with this 2 that's on the base. This here, I'm just going to slide on it, be x minus 1. So the log base 2 will actually cancel each other out, leaving behind y minus 2. And this will be log 2 x minus 1. Oh, I think I just realized this should be a 3. I don't know if anyone caught me on that. I just didn't see. That's a 3, so this should be all a 3. My bad. From here, notice how y is almost by itself. We just need to move over this 3. So I'm going to add 3 to both sides. So if I add 3, this will cancel. Y comes down. This will equal log x minus 1 plus 3. And so this here is my equation. All I need to do is replace the y with the inverse y. And so this is y inverse equals that equation I just found. And now I have my answer. Okay. This next one here is log base x plus 3 minus 1. So to solve out this problem here, I do need to try to get the log by itself. But before I do that, let's switch the x's and y because we're finding an inverse. So we're going to add 3 to both sides. That cancels. X plus 3 is on this side. Log 3y plus 1 is on the other side. So from here, I need to try to get rid of this log because y is inside the log. So to get rid of this log, I need a base of 3 to cancel out with that log base 3. So I have to use a base of 3 on this side. Y plus 1 comes down. This is 3x plus 3 power. From there, I need to subtract over this 1. Cancels. So y is equal to 3x plus 3 minus 1. If I write this as a inverse notation, this would be 3x plus 3 minus 1. Kind of long here, but very doable. Okay, I hope this helps you out with your homework and a better understanding on how you find inverses and solve with logs. Until next time, guys. Bye.